The topic today is the structure of the atom. What are atoms? Atoms are the building blocks of matter. Atoms are the smallest unit of an element, but atoms are different elements. Atoms of different elements vary in size. Atom consists of central nucleus surrounded by one or more electrons. Three main types of particles that make up all atoms are protons, neutrons, and electrons. These particles are called subatomic particles. Let us look at the characteristics of these subatomic particles. Using this simulation, we can look at each characteristics of subatomic particle, and also we'll be able to build an atom. Okay, so the three subatomic particles of an atom are the protons, neutrons, and electrons. I need your participation here. Look at this screen very well. Look at the way it is now. I will put each subatomic particle, and based on what we observe, we can tell the characteristics. Okay. Look at net charge, mass number. When I put it here, you will look at where it is located in the atom. Okay. Look at this. What do you observe? What do you observe that wasn't there? Hopefully, you see the name hydrogen. You see the proton is located in the nucleus. You see the positive ion. You see the positive charge here. The net charge is +1. The mass number is 1. Okay. Now, let's reset and look at another subatomic particle. So the proton is positive. We're able to see the name of the atom. It's located in the nucleus. It has mass number of 1. Okay. Let's look at another subatomic particle called neutron. Okay, here we go. The neutron, there's no name. It's in the nucleus. Its net charge is 0. Mass number is 1. Okay. Let's look at the last one. Okay. Take a look. Make sure. Okay. Now, pause the video. Pause the video and write down what you observe, everything you observe. Hopefully, you say that is not in the center this time. The electron is outside. Okay? And then is negative, and the mass number is 0. So we're able to look at 3 things. We looked at the location, we looked at the charge, we looked at the mass number of the atom. We looked at, we've been able to figure this out. Okay. Let's look at what you just observed. If we saw these 3 subatomic particles, but then I think to explain this, let's go back and build an atom. Let's build a simple atom. Remember, an atom is made up of 3 subatomic particles. So let's build an atom. Let me put, you see, when I put the proton, the name shows up. Guess what? Look at that. I'm trying to build a simple atom. Neutral atom. Neutral atom. This is lithium atom. It has 3 protons, 3 neutrons, 3 electrons. It says here neutral atom. Why does it say neutral atom? Try to answer the question. Why do you think it's neutral? Pause the video and think about it, analyze it. Hopefully you did. You find out there are 3 protons that are all positive, 3 electrons that, so that's why the net charge is 0. That's why it's a neutral atom. Atom is neutral where the number of protons and electrons are equal. Okay? Then it says mass number 6. Why is it 6? Because mass number is total number of protons and neutrons. Remember, in this, we call this the nucleus. Nucleus. The center of the atom is called the nucleus. And in this nucleus, you have 3 protons and 3 neutrons. So the total number is called, the mass number is 6. The modern day atom, this is a Bohr model. This is a Bohr model. So the modern day atom does not look like this. The modern day atom looks like this. This is a modern day atom. So the electrons are in the electron cloud, while the protons and neutrons are in the nucleus. And these protons and neutrons together, they're called nucleons. Okay? So this, we just built an atom, lithium atom. You can choose to build any atom you like. Let me put this back here. Let's say I want to build beryllium. You see, look at this. And I want it to be neutral. Maybe I add another one of this. You see that? Beryllium. Protons and neutrons, number of protons and neutrons are equal. That makes it neutral atom. The electrons are located in the electron cloud. The protons and neutrons are in the nucleus. Look at that. The reason we use this for convenience because it's easier. We can tell, see every electron, see everything. Though modern day atom looks like this. But for convenience, for better understanding of what is happening, we are using the Bohr model. We call this Bohr model. Okay? Let's go over what we just discussed. As we looked in the simulation, this is positive, this is neutral. So this is what is in the nucleus of the atom. The central part of the atom is the nucleus, composed of protons and neutrons. Together, they are called nucleons. Most of the mass of the atom is in the nucleus. Then, proton is positively charged, is located in the nucleus, okay? The atomic nucleus. Neutron is uncharged particle found within an atomic nucleus also. Then electron is negatively charged and is located outside in the electron cloud. It has a very small mass. Okay? Then mass number is the total number of protons and neutrons as you observed in the simulation. Everything, protons and neutrons are, both of them are in the nucleus. Okay? So together, they're called the mass, mass number. The mass number equal to number of protons plus number of neutrons. Then this is a modern day atom. Okay, you see electrons are in the electron cloud. You see the proton. This is the nucleus of the atom. Every here, the Lebanon is kind of not very clear. Everything here is the nucleus. Okay, the neutron is the one that has no charge. The electrons are located in the electron cloud. Then atom as a whole is electrically neutral. Every atom is neutral. Why is it neutral? As you saw in the simulation, number of protons equals the number of electrons. And also, you notice that the number of protons defines the atom. You find out that each time you add a proton, the name changes. The proton is more like social security number, our social security number, unique number every one of us has. Proton, each proton, number of proton is, each atom has unique number of protons, which no other atom will have. If we say the number of protons is 6, there's only one atom that can have that number of protons. Okay? Let's look at the periodic table. Let's look at the periodic table. This is called periodic table of elements. Periodic table of elements. Everything you have here is an element. And we have to understand, there are a few things we have to understand here. We still do periodic table in future. Now, this box is a key. It's telling us about every information of an element in this periodic table. Any number on top here is called atomic number. This is called element symbol, like we looked at it in the last video or 2 videos. Then element name, like this one is sodium. The symbol is Na. Then average atomic mass is this number below. Okay? So this atomic number is unique number of each element. No 2 elements have the same atomic number. It's like ID number. If I say an element with atomic number 6, there's only one element that can have atomic number of 6, that's carbon. You see that? So this periodic table is arranged in order of atomic number. You see, it goes 1, 2, 3, 4, 5, 6, 7, 8. You see, like that. So we now understand what each of these means. Then we also, all these elements are neutral. Every element in this periodic table is neutral. So that means the number of protons and electrons are equal. They're the same. So if this is carbon, it has atomic number of 6, then the number of proton is 6. So atomic number is the number of protons. Atomic number is the number of protons. So if we say atomic number is 6, it means the number of protons is 6. It means the number of electrons is 6 because a neutral atom has equal number of protons and electrons. So as discussed, for every neutral atom, number of protons and electrons are equal. We also saw in the simulation that when you have whenever you change the number of protons, the identity of the atom changes because the number of protons identifies the atom, which is more like the social security number. Okay. So each element has its unique number of protons. And then atomic number is the number of protons of the atom. If the atomic number is 6, the number of proton is 6. Okay. Yeah, so to emphasize again, all elements in the periodic table are neutral. All of them are neutral. If we say nitrogen has atomic number of 7, then it means the number of it means the number of protons is also 7. So atomic number is the number of protons in the nucleus of an atom. Periodic table is arranged in the order of atomic number. Let's look at this example. If atomic number of carbon is 6, that means the number of protons will be 6 because atomic number is the number of protons. Then the number of electrons is 6 because it's a neutral atom. Okay, because it's a neutral atom. Pause the video and answer this question. Pause the video and answer this question. Hopefully, you're able to answer it correctly. Here we go. So the 3 subatomic particles of the atom are protons, neutrons, and electrons. Their respective charges, yes, proton is positive, neutron has no charge, electron is negative. Okay. So hopefully you got everything right. I also want you to build an atom. Any atom you like. When you build it, you draw it, and then from the simulation, you can answer all these questions. Protons, the charge, the mass number, the location. Okay. So if you get that right, that means you understood the lesson. I hope it makes sense. Thank you for watching.